Good morning. This is Chinnaraj. In this video, we discuss about the types of the functions and some problems. So first one is bijective functions. A function f is said to be bijective. It is both on1 and on2. So bijective function means a function is satisfy the condition on1 and also on2. So on1 means every element in domain has a image in codomain, and onto means every element in codomain has a pre-image in domain. That means on1 function is defined on domain, onto function is defined on codomain. A function satisfies these two conditions. The function is called a bijective functions. So bijective means on1 and onto. So see the examples. So bijective functions. First one is the domain contains elements t, u, v, and codomain is 5, 2, 1. So this is a function. That means every element in domain has an image in codomain. So this is a on1 or not. On1 means every element in domain has a unique image in codomain. The image of t is 5, the image of u is 2, the image of v is 1. Every element in domain has a unique image in codomain. Therefore, it is a on1 functions. So next one is verify onto. Onto means every element in codomain has a pre-image in domain. So we can take the element in codomain. So in that function, the codomain elements are 5, 2, 1. The image of 5 is t. The image of 2 is u. The image of 1 is v. Therefore, every element in codomain has a pre-image in domain. Therefore, it is an onto function. So it is satisfies on1 and also onto. Therefore, this is a bijective functions. And second one is not a bijective function. The function satisfies either one. That is, it is not satisfy on1. It is not a bijective, or it is not a onto. It is not a bijective function. Satisfies any one function. Is not the function. It is not satisfies any one function. It is not a bijective function. So first one is x, y, z, and the elements are in codomain is 1, 2. So it is a on1 or not. On1 or not. It is not a on1 because every element in domain has a unique image in codomain. So every element. So in that function, the element x and z have the same image in codomain. Therefore, it is not a on1 function, but it is a onto functions. Onto means every element in codomain has a pre-image in domain. The pre-image of 1 is x and z. The pre-image of 2 is y. So it is not a on1 function, but onto function. So bijective means both on1 and onto. So it is not satisfied on1 condition. Therefore, it is not a bijective function. So next one is same. It is not a on1 and not a onto. We can add the extra one element in 3. So there is in the codomain, the element 3 has no pre-image in domain. Therefore, it is not a onto. It is not on1. It is not onto. Also, it is not a bijective functions. So next one is composition of functions. Let f is a function from a to b and g is a function from b to c. Be two functions. Then the composition of f and g denoted by g composition of f is defined as the function of g composition of f. It's a function from a to c given by g composition of f of x is equal to g of f of x for all x belongs to a. This is a definition of composition functions. The definition is g composition of f of x is equal to g of f of x for all x belongs to a. Similarly, f composition of g of x equal to f of g of x for all x belongs to a. Next, see the example of composition of functions. If the two function f of x equal to 2x and g of x equal to x plus 1, then you can find out the f composition of g of x The solution. The given functions are f of x equal to 2x and g of x equal to x plus 1. We know that f conversion of g of x equal to f of g of x. F of g of x is x plus 1. F of x equal to 2x. Therefore, 2 into x plus 1. This is a value for f conversion of g of x. So next second example is given function f of x equal to 2x plus 1 and g of x equal to x square. You can find out the g conversion of f of x. The given function are f of x equal to x plus 1 and g of x equal to x square. To find g conversion of f, g conversion of f of x equal to g of f of x. Therefore, g of f of x equal to g of f of x value is 2x plus 1 and g of x equal to x square. The x value is 2x plus 1. Therefore, g of x equal to 2x plus 1 whole square. This is the value of g conversion of f of x. Okay, thank you.